So to graph this, then we know that, as we mentioned earlier up here, okay, as we mentioned up here, it's going to have a tail behavior that goes to negative infinity and positive infinity because the leading coefficient is a positive one. And we know its x-intercept is at -2. That's helpful in graphing. It's also part of the reason why I solved it. Okay, so we have a congenital shape. We also know that if we plug in x equals 0, we get a y-intercept of 8. Now, since this is just a cubic function, right, we know that the parent function of a cubic sort of has this general shape. So it has this general shape where this kind of like little saddle point right here usually occurs at 0, 0 for f of x equal to x cubed. So this is just a translation of this graph, actually of 8 units. So we can make a pretty accurate sketch with just that information. So if we pull these out, okay, it's a pretty steep function because it's x cubed. And so we know that over here at, I'm going to make this point right here in units of 2, 2, 4, 6, 8. Okay. So these are going to be all in units of 2. So here our functions coming in at, and it kind of has a little bit of a 2, 4, 6, 8. It has a little bit of a, so it's going to be a pretty steep function. So the general shape here, of course, we have a little bit of here. It's a little bit exaggerated for the purposes here, and this is probably a little bit steeper here. So just trying to get a sketch of it. We know that the x-intercept is at -2, 0. Okay, so that's the x-intercept. We know here it has a y-intercept. I think that's showing up okay. Yeah, y-intercept of 0, 8. Plugging in 0 here for the x value, you get that the y-intercept is 8. We know that it goes to negative infinity when x is less than 0. And it goes to, the tail behavior goes to when x is greater than 0. The tail behavior goes to positive infinity. Okay, so that's a really good sketch with some of the key points indicated in on the graph. Okay, I hope that was helpful, and I'll see you in the next video.